Hello everyone, welcome back to the another session in design and analysis of algorithms. So this video is about Prim's algorithm. This is continuation part to the earlier video, which is minimum cost spanning tree. So there we were discussed about there are two techniques to find out minimum cost spanning tree of a graph. So this is one of the technique which is Prim's algorithm. Now as far as Prim's algorithm is considered, a greedy method to obtain a minimum cost spanning tree builds this tree by edge. So Prim's algorithm is what? It's a greedy method. What we will be doing, where we will be applying greedy method? Greedy method is applicable on optimization problem. So this is minimization problem. Minimum cost spanning tree is minimization problem and we will be applying greedy method on it. So the next edge to include is chosen according to some optimization criteria. That criteria is what? Minimum cost of the edge. And that minimum cost is also not from the graph but from the vertex which is connected to the selected edge. Now we'll see an algorithm and later we'll see an example also. So here let us assume that I have a graph 1, 2, 2, 2, 3. Now assume that the cost of this edge is 10 and the cost of this edge is 20. Now as far as take this as 35. Now it is a graph where it is having 3 vertices. If I wanted to find the spanning tree from this graph, I have to take 2 vertex only, right? Because your spanning tree formula is what? Number of vertex of the spanning tree should be as the equal to number of vertex of the graph. So if the graph is having 3 vertex, your spanning tree vertex also 3. If edges are 1, 2, 3 in your graph, so here in the spanning tree edges will become v minus 1, that is 3 minus 1, which are 2. So now any 2 we have to consider. So this is what actually feasible solution, that you can take 1, 2 or 2, 3. One feasible solution. The other feasible is what? Or else you can take 1, 2, 3 and 3 to 2. That is also feasible. But here we are given with a constraint. That the constraint is what? We have to select a edge which is having minimum cost. So now Prim's algorithm will work on this graph to find out minimum cost spanning tree, and that is selecting of minimum cost edge. Among these 3, which is minimum cost? 1 to 2 is the minimum cost. So we'll select this one. Now to select the next edge, we will be selecting the minimum cost which starts from second vertex, the minimum cost which starts from one vertex. So there are 2 cost what you have to compare, which is 35 and 20. So among these 2 we'll select only this 20. Now we'll trace this algorithm. So let k comma l be an edge of minimum cost in E. So now 1 comma 2 is represented as k comma l. So cost of k comma l is what? 10. So k comma l is what? 1 comma 2. Now after that we will be giving cost of k comma l into minimum cost. Now the minimum cost is what? 10. Later we will be taking t 1 comma 1 is equal to k, t 1 comma 2 is equal to l. That means spanning tree first vertex is what? K. Spanning tree second vertex is what? L. Now we are starting a loop in order to compare cost I comma l less than cost I comma k. That means cost I comma l is this, cost k I comma k is this. We will be comparing these 2. So when you compare these 2, whichever is having less than, so cost I comma l is, if it is less than, then that will be considered as a solution. Now near I is equal to l. If it is not less than, then near of I is equal to k. Now so once after you find this thing, again we are initializing into 0. So our loop will run from the second vertex. Now this is your connected vertex. This is what Prim's algorithm. Now so again we will be considering the same loop for the other vertex which starts with 2, and we will be joining all the minimum cost of different edges, and we'll be finding out the sum of minimum cost selected edges. So this is what the algorithm of Prim's algorithm. Now, so I have given some example over here. This example I took directly from the question paper, OU question paper. Now, as far as the algorithm is considered, you have to select one edge which is having minimum cost. So I am selecting, the very first step is what? Selecting the minimum cost edge. So once I selected the minimum cost edge, which is 1 to 6, now you cannot take the other minimum cost. You have to proceed with the connected edges of this. So what are your edges? Vertex 1 to 6 is your selected edge. Now you have to select the edge which is from 1, which is from 6. So only connected vertex, not all the other vertex, only connected vertex. So 1 is connected, 6 is connected. Now find out what edge is available with 1, what edge is available with 6. Once you found edges of 6 and 1, later you have to compare these two costs. If whichever cost you found it is minimum, that edge will be considered. So now 6 to 5 edge will be considered, which is 25. Now you are at what? You are at 5th vertex and here 1. So there are two vertex where you have to compare. From 1 you have 28. From 5 you have 5 to 7 edges there, 5 to 4 edges there. So now the comparison in between, minimum of 22, 24, 28, which is minimum, 22 is minimum. So add the solution, which is 5, 4 edge, 22. Now you are at 4th vertex and the one end is 4th, the other end is 1. Now again comparison in between 1 to other vertex and 4 to the other vertex. Whichever is minimum, that will consider. Now 4 to, you have 3 edges. 4 to 3 is one edge, 4 to 7 is the other, and 4 to 5 is the other, and 1 to 2 is the other. So among these two, whichever is minimum, that you have to consider. So minimum of 22, 18, 12, 28, which is minimum, 4 to 3 is minimum. Now take 4 to 3. So you are at 3 and you are at 1. 3 and 1, these are what? Connected vertex. Now from 3, how many edges you have? Only one edge, 16, and it is 28, which is minimum. Minimum is 16. So you can consider this into solution. Now you are at 2 vertex. From 2, how many edges you have? 2 to 1, 2 to 7. So 2 to 7 to 2 is what? It's 14. I'm sorry I didn't mention. Please make a note, it is 14. So I told you that I have taken this example from the question paper. It is given as 14. Now, so 2 to 7 is 14, 2 to 1 is 28, 2 to 3 you already visited. So you are no need to take that one. So now minimum in between 28, 14. So minimum cost of 14, 28, which is minimum? 14 is minimum. So now this is what your spanning tree. Why the reason I have ended over here? Why the reason I'm not moving further? Because I have visited all the vertex. I have visited all the vertex. As far as spanning tree is considered, spanning tree is what? S is equal to V dash. Whereas V is equal to number of vertex, E is equal to number of vertex minus 1. So number of vertex for this graph is 7. 7 minus 1 is what? 6. So I should get total 6 edges. Now you can see that 1, 2, 3, 4, 5, 6. Now it is spanning tree. So it is minimum cost spanning tree. What is the cost of this whole thing? Cost is 10 plus 28, 25 plus 22 plus 12 plus 16 plus 14, which becomes 99. So it is what cost of the matrix. Now if you see this thing, what we are doing is, the analysis of this process is what? You will be going for each vertex, right? So each vertex you are finding out the number of edges. Likewise, you will be going for n vertex for n times. That is of theta n square. Okay, now I'll write this in neat way that your graph is what having vertex and edges. So vertex are nothing but number of vertex n into e. So once this e will be equivalent to n, then that is theta n into n, which is theta of n square. The time which is required, the maximum time is required theta of n square to compute this. So this is about Prim's algorithm to find out minimum cost spanning tree. So next video we'll discuss about Kruskal algorithm. Thank you all.